Welcome, I'm Ng a 4th-year student from USM Computer Science. I would like to present you my project, which is ECOSAIL, an autonomous sailboat for environment monitoring. Due to the rapid population growth, coastal developments have been bringing out to increase the coastal zone for population beneficial and livings. But recently, many environment groups, especially fishermen, have demanded the cancellation of the proposed Penang South reclamation project because they are worried about the adverse impacts that cause to the surrounding environments and the marine life. But due to the situations that we lack of data and evidence to support whether this coastal developments is suitable to be carried on or not, and what is the impact to the initial state of the water quality that affects the coastal marine environment. Besides, there is no any alert to inform the user whether the water quality is in an unhealthy state that may threatening the marine life. In order to get those water quality data, researchers are required to go down to the sea to manually and continuously collect the water quality data. And those collected data are just represented for that particular static sea area. In order to get a large sea area analysis, they have to move to multiple areas to collect the data, which is a very tedious and tiring process. To address the issues mentioned above, ECOSAIL aimed to develop a control system and navigations for an unmanned sailboat that fitted with various sensors to drive itself autonomously to a user-specified location. Then, a water quality analysis system is able to collect and analyze the collected water quality data and capable to generate the water quality notifications when the water sensors met the threshold limit. Last but not least, the web and mobile applications for the users to remotely monitor the water quality data and also control the destinations for the sailboat to collect the water quality data. Next, technology deployed. The main component part of this project is the sailboat. Then we will have the IoT devices, which is the actuators, servos, and the sensors, and of course the MCU. Then the languages involved is the C, C++, Python, and the framework used are the rules framework for the mechanics and IoT communications. Then React.js is used to design the front end, and Express.js as the backend. To shorten the development time and reuse back the code, Apache Cordova is used to convert the web applications into mobile applications. Then we will look into the architecture diagram where the sensoring node, which is the sailboat itself, will have these components, which is the control sensors. Inside there we'll have the rudder, wind servos, and wind sensor, GPS, and IMU. While the other sensors that will play a role to collect the water quality data are the water sensors, which are pH meter, electricity conductivity, dissolved oxygen, temperature, and turbidity sensors. Then all these sensors data will be collected in the IoT node and merged. And then this merged sensors data will send to the IoT gateway via the Zigbee. Then the IoT gateway will just upload this merged sensor data to the cloud, which is a backend. Then the cloud server will process and analyze this data. Then the informations can be retrieved back in these web and mobile applications. After that, so we assume all the hardware systems are being set up and the sensors are in a good status. Then the user has to authenticate himself or register a new account if he doesn't have any. So he or she will need to set up the boat destinations, and this destination data will be sent to the IoT node. The IoT node receives this destination data, will straight away launch the navigation strip and upload the sensor data to the cloud. Then the real-time data or the informations can then be viewed in the dashboard in the application. Aside from that, the sensor status are also included to support the user to know that all the sensors are in a good status or when the sensors are in a loose or malfunction status so that they can just go and replace it or reconnect it. When there is any sensors value that met the threshold limit, a notification will be generated. then these notifications can be reviewed in the notification feed. So what this notification feed does is that it will keep track those notifications so that user won't have to worry if, let's say, he or she has missed out any notification. Last but not least, the historical data can be previewed in two forms, which is the analytics map and the graphical form. The analytics map is meant for the trip path and provide node information, while the graphical form will provide the data trend and also the active time of those collected data. So what is the impacts and the benefits? ECOSAIL brings a more advanced and better way to collect those water quality data in the sea areas. Then the collected data can be monitored immediately in the application and notifications generated can be reviewed. The historical water quality and the data locations is recorded so that the user can review it in either analytics map or the graphical chart. So it will depend on user needs to whether they want to see the path and the node informations or to view the trend of the data for further analysis. So let's proceed to the demonstration.
The water quality sensing system and the microcontroller is being set up and connected. All the sensors is then pulled up to get the water quality data. The boat also connected to the microcontroller within the white container. Lastly, user has to set the destinations for the boat to go with the application. So now we can see that the boat is navigated itself from the starting point at the poolside and will reach to the destination's point, which is the other end of the poolside. When the MCO has been announced, the navigation test has been held. Thus, the focus of the project has shifted to analysis part. The following part will show the analytics map with the traverse path and infected area. So we started from 0 and there is no any data currently. So the boat and the sensors is set up in the car to represent the boat movement during this MCO period. The tested sample is lemon juice and tap water. As you can see in the video, the water and the sensors and boat is being set up as shown in figure. So the first point, which is the red circle, is the starting point. And the following point, the blue circle, which is the destination point, that will always place as the last point of this trip. So the previous blue circle will be turned into the green circle as the traverse point. So all these traverse point and the starting and the end will form a trip path. Next, we will move all the sensors into the lemon juice to simulate the infected points and notification. So we can see that the pink circle that has been formed will be called as the infected point, and the big circle covers those infected points. We call it a infected area. That it can dynamically locate the circles to cover all these infected points. So now we got all the water quality data for the round trip, and let's check those data that we just collected. So we can just zoom in and then we can check those data informations that we just collected. And the red font indicate that the sensors value that has met the threshold limit. There is also a note for user to know what are those circles represent for. And Not to forget to mention, user can also select to present those historical data either in graphical or analytic form. In this graphical form, user can review back those collected data in the bar chart. And also, the summary data is provided for user to view the pattern and for analysis purpose. Last but not least, the received notifications can be reviewed back in the notification feed in the toolbar. Thank you for watching.